Canadarm2 is a robotic system in charge of mobile servicing on board the International Space Station. Before discussing Canadarm2, it is important to mention that there are two different Canadarms, Canadarm1 and Canadarm2. The main differences between both is that Canadarm1 comes back to Earth after a shuttle mission, whereas Canadarm2 is permanently anchored in space, attached to the International Space Station. Canadarm2, formerly known as the Space Station Remote Manipulator System, is the robotic arm attached to the International Space Station. It was designed and built in Brampton, Ontario by the Canadian company McDonnell Detwiller and Associates. The arm is the brainchild of three engineers, Savi Sanjdev, Devendra Kusain, and James Middleton. The arm was launched in April 2001. The initial use of Canadarm2 was to complete the assembly of the International Space Station. Major components of the ISS installed by the arm include the Quest airlock and the Columbus laboratory, launched in 2001 and 2008 respectively. Ongoing uses include catching and docking unmanned spacecraft arriving at the ISS, as well as moving equipment, supplies, and even astronauts to support maintenance and repairs. One additional feature of the arm is its attachable extremely dexterous mobile hand, aka Dexter, also designed and built in Canada. In 2013, the arm actually set the record for the most number of hours of research performed in space, with approximately 130 experiments. Canadarm2's engineers wanted to design the most dexterous and accurate space robot possible, leading to a 1,640 kilogram and 17.6 meter long arm possessing 7 joints. The joints are configured roughly like a human arm, with a shoulder, an elbow, and a wrist, although there is no difference between the shoulder and the wrist sections of the arm. A key feature of the arm is that it is capable of moving around the ISS by grasping and releasing handles using robotic hands on either end of the arm. Its movement can be compared to one of an inchworm. This means it does not have a particular orientation, as each end is capable of attaching to both the ISS as an anchor and to any other compatible component. The arm is accompanied by a mobile-based system that allows it to glide 108 meters down the main rails of the space station. In addition to being very ductile, the arm is capable of handling the weight of a shuttle, which is around 1,600 kilograms. However, the arm is not capable of carrying a load and relocating simultaneously. The arm is powered by only 1,200 watts, which is the same as a hairdryer. We have a material called thermoplastic, composed of 19 layers of carbon fiber composite. It has a maximum speed while unburdened of 37 centimeters per second. The parts of Canadarm2 are designed to be easily replaceable by robots or astronauts while the space station is in orbit, meaning the arm may never need to return to Earth. The control of the arm takes place in the cupola. Windows surround the cupola so the controllers can see what they are doing. In front of them, the operators also have 3 screens that show different camera views from around the space station. The cupola has all the controls necessary to operate the arm. It has the main computer interface that possesses all the displays necessary to control the arm. There are 2 main hand controllers. On the right is the rotational hand controller, and on the left, the transitional hand controller. Obviously, because the arm is in space, the astronauts feel weightless. So to keep them stable while controlling the arm, they have to stick their feet right under here. Every astronaut who uses the Canadarm2 needs to participate in a 2-week training session where they simulate commands with the exact replica of the controls inside the cupola. The main types of engineering involved in the design, construction, and operation of Canadarm2 are mechanical, electrical, and materials. Mechanical engineers are responsible for the design of the motorized joints of the arm, as well as the design of each of the individual components that make up the arm. Electrical engineers designed the hardware and software needed to control the arm, and materials engineers were responsible for the creation of the thermoplastic most of the arm is made up of. All of these pieces contribute to the successful operation of Canadarm2. In addition, Dexter, the attachable hand of Canadarm2, is considered to be the most sophisticated space robot ever built. Dexter, not surprisingly, is extremely dexterous. It performs delicate maintenance and repairs on the space station thanks to its dual arms. The technology behind Dexter is finding its way to modern medicine. Firstly, the Hospital for Sick Children of Toronto developed their own version of Canadarm, Kidsarm. This technology is designed especially for pediatric surgery to perform intricate procedures like the suturing of blood vessels and tissues. It is capable of working 10 times faster and with more accuracy than a surgeon. Secondly, researchers at the Center for Surgical Invention and Innovation also heavily based their design of EGAR on the design of Canadarm2. EGAR is promising platform for patients that have a high risk of developing breast cancer. It is the first robot designed to work inside the MRI scanner. Due to its delicacy and precision, it will be able to execute biopsies with extreme accuracy, helping detect and treat tumors from lung, liver, kidney, and prostate cancers. It might also be useful for delicate spinal surgeries. It is also interesting to add that images of Canadarm2 appear on a commemorative coin released in 2006 by the Royal Canadian Mint, as well as on the current Canadian $5 bill.